right, guys, so section 7.3. Right now, the game plan is I'm going to teach you 7.3 today. I want to teach you 7.4 tomorrow, and then your homework tomorrow night will be the review to get you ready for the quiz. Yeah. Okay? Yeah, we'll have homework tonight over what I'm teaching you right now. All right, so we're going to actually write and evaluate logarithmic expressions today. That button on your calculator that says log? Fun! So use it some, but we're not going to use it the whole time today. All right, so straight out of the textbook. You know how I always hate textbook stuff. It always looks so complicated. So in other words, what I kind of talked to you about some of this. Logarithms, they're used to solve for exponents. That's what they're used for. Because it's not always nice and pretty, so we're not always sure what they are. So anytime you're seeing logs, you know that you're going to be solving for an exponent. So if you look at this right here, by definition, log base b, make sure we understand how to read these, log base b of y equals x. So that's how you would read that. Log base b of y equals x. I know you're like, wait, what? So the base right here, base b, we'll talk about that today. So what this is referring to, shows it over here. To me, it's like a loopy swoopy type thing. That's how I always memorize it. I know, right? The loopy swoopy. So b to the x power equals y. Loopy swoopy. Because if you look over here, that's exactly what that says. That's true only if b to the x power equals y. So we're going to practice first going back and forth between logarithmic notation and then exponential notation. Because you can write them back and forth. Okay? So, getting a little practice, if we look at this first one, log base 5 of 25 equals 2. So if you do the loopy swoopy, switch, that's a technical term there. That means 5 squared equals 25. That's Mrs. Solner's technical terms. You know me, I like stupid ways to remember things. Whatever works. So if I give you log base 4 of 64, and again on your notes you'll have to fill this in because it's covered up on your notes. As far as they're all correct. I'm not asking you right or wrong. I'm asking you to switch it into exponential form. 4 to the third equals 64. Because we're going to have to switch back and forth. Oops, I made my arrow too far. We're going to have to switch back and forth between the two forms. Okay. So log base 7 of 1/49 equals -2. So how would you switch that to exponential? Good. 7 to the -2 power equals 1/49. Right? Keeping in mind negative exponents would push that to the bottom, and then 7 squared is 49. Log base 32 of 4 equals 2/5. Very good. 32 to the 2/5 power equals 4. Now, Alex at first was saying true for all of these. They are true. Okay. Again, the point of this is to be able to switch back and forth between these, because eventually, probably not this year, you would get into solving these things, and you'd have to be able to switch back and forth between the two forms in order to solve equations with this stuff. Okay? So log base 36 of 6 equals half. So 36 to the half power equals 6. Remember, half power really means square root. Okay, so going from one form. To me, it's easier to go from log form to the exponential form. It's harder for me to go back the other direction. Alex? Since it wants exponential, you would need an exponent. But it's not wrong, but that form needs to be an exponent. Bless you. All right, so here we have to go take it backwards. To me, this is the one that's a lot harder. So 5 cubed equals 125. How would you write that in log form? All right, so I heard a couple things. Let's kind of talk about it. I heard most of you got down log base 5. But then I heard it both ways. I heard 125 equals 3, and I heard 3 equals 125. Good. Because again, think about the loopy swoopy for how you're doing this. So what would be a good way to kind of memorize how to do this? The 5, the big number, is which part? That's your base, so it's the first number you're writing in, right? And then these are the opposite direction. So the 125 jumps across the equal sign and 3 hops over the other side. It's kind of backwards. So 81 to the 1/4 equals 3. Of good. Log base 81 of 3 equals 1/4. Yeah. Can you see though why it's easier to go one direction than the other? Okay, so that one. Good. Is it still kind of loopy swoopy? Yeah. Kinda. The order I'm writing them is this number, then this number, and then that number. So the same order as your loopy swoopy. Yep. Loopy swoopy. 7 to the 0 power equals 1. True. Of 1. Log base 7 of 1 equals 0. Nine to the 3/2 equals 27.
Log base of 9.
All right. It's all right. Do we understand the concept, though? Doesn't matter if you're fast or not. It's hard because it's different, and at this point, you're still like, what the heck's log for? Like, right? We haven't really talked much about what it means. Log is like an operation. It's like running a set of numbers on your problem for you. It's doing something for it. There you go. It's a log rolling. All right, so let's have you evaluate each log. So in other words, I want you to solve this. What is log base 2 of 32? So what am I really asking you? Think about loopy swoopy. I'm asking you 2 to what power equals 32? That's what I'm asking you. 2 to what power equals 32? That's what a log is doing. Now, don't touch your calculator and hit the log button, because we haven't talked about this yet, and we will in a minute. So you need to actually use your brains for a minute. 2 to what power equals 32? The 5th. Magical. That's the way I made it. All right, how about this next one?
0.
Good. It's asking you 3 to what power equals 1? So when you're solving this, it is 0. Anything to the 0 power equals 1. Okay, hold on. Let's give everybody a chance to think, okay? So 4 to what power equals 2? Right, because the square root is 2, so it'd be half.
That is magical.
Cool, right? And then down here, here we go. 10 to what power equals 1 over 100? Don't say anything out loud yet. Give everybody a chance to think about it. Appreciate that. So again, 10 to what power equals 1 over 100? I can see the wheels turning right now.
Good thing I have a small view.
Jesse? -10? Alex? -2? Any other options? Paige, what were you going to say? It's -2. Again, recognize that it has to be negative, right? To push this 10 to the bottom of your fraction, it's going to have to be negative. And how do you make 10 100? You square it. You got to be thinking exponents. You multiplied it. Now, your quiz on Friday, the first page of your quiz will be separate from the other page of your quiz. You will turn it in to me separately because the first page is no calculators allowed. There will be 8 questions. I believe it's 8. That's problems like this that you will have to do without a calculator. Because I'm going to teach you tomorrow how to make the calculator do this for you. I'll teach it to you. But we need to know how logs work. So the first page is no calculators. You will have to tell me how to do this. Yeah. How we did any of those? We're looking. So like on this one, 3 to what power equals 1? Like, are you okay with the loopy swoopy how logs work? So 3 to what power equals 1? So you're at this point, because I haven't taught you, tomorrow I'll teach you how the log stuff works with this. But what exponent, 3 to what exponent equals 1? You just have to recognize it's 0. Same thing up here. 2 to what power equals 32? So what exponent, 2 to what power would make 32? Well, even if you didn't know, 2 times 2 times 2 times 2, like you could do the math and figure that out. So yeah, you're just kind of playing that. And again, if you're not great with your basic math, that's gonna hurt. But you're good at basic math. You should be all right. All right, and like this one, 10 to what power equals 1 over 100? So if I rewrite it this way, you gotta think about, okay, I need to push it to the bottom, which is gonna make it a negative exponent. So if I push it down with negative, how do you make 10 100? You square it. So it'd be negative 2. That's why it's negative 2 over here. Make a little sense? Okay, so evaluate the logarithm. So here's just a little bit more practice with it. So I want to give you guys a couple minutes, and I want you to figure it out for me, okay? All right, so the first one up here. Again, this is saying 4 to what power equals 64? I heard 3 and I heard 4. 4 times 4 is times 4. All right, this one again is saying 1/5 to what power equals 125? 3? It is negative 3. Again, how do you get the 5 to not be in the bottom of the fraction? It has to be a negative exponent to move it, again. And then 5 to what power equals 125? 3. So it'd be negative 3. All right, so the next one is asking you 5 to what power equals 0.2 is the same as 1/5. 2/10, which is 1/5. So, Alex? That would be correct. Again, the negative is going to move it down and then just to the first. And then this one is saying 36 to what power equals 6? 3? That is 1/2. Because that'd be, to the 1/2 power would be taking the square root of it. To write it this way? Yeah, it definitely does. Questions so far? Negative 3? Math. We did math. Recognizing to move, right now it's in the bottom of a fraction, and we need to get it out of the bottom. So a negative exponent is going to move it back to the top. Negative exponents always move them up or down. So moving it up, and then 5 cubed is 125. Doing okay? For the most part? Can you use your calculator on these? Meaning, can you use the log button on your calculator? Try it. Of course there is. I just haven't showed it to you yet.
Wait, I want to figure it out.
You probably won't. Reason being, and I do want to kind of talk a little bit about stuff today with this. Your calculator uses what's known as the common log. okay? So a common log has a base of 10. So anytime you're using the button log on your calculator, it's log base 10. And you can't change it. All right, so in your calculator, it's log base 10. So all the things that we've been doing that have different bases, you cannot directly type into your calculator. Tomorrow, I'll show you a trick to make it do other bases for you. That's a trick. Yeah. See you later. All right, so this right here, log of 10, really means log base 10. So if you ever see a log and there's no base written, it's assumed to be a 10. And normally we assume things are 1 if we don't see them, but in this case, the common log is a base of 10. So that's the way it would be written. So then what is log of 10? Why is it 1? Right, it's asking 10 to what power equals 10. 10 to what power equals 10 would be 1. There we go. It is factual. All right, so grab your calculators this time. Just to make sure, he does. Just to make sure that we are comfortable with the buttons on your calculator. Does everybody not find the log button? Just want to make sure we're there. All right, so go ahead and type in log of 100, and you get? You should get 2. Why do you get 2? Because remember, the base is 10, so it's asking you 10 to what power equals 100, which would be 2. That's why it gives you 2. So again, calculator, if it's just a common log, we can use the calculator. The log of 1 over 100 is negative 2. Again, because it just needs to push it down to the bottom. All right, how about log of 1? 0, because 10 to what power equals 1? 10 to the 0. Log of 0.1? Negative 1. Again, it's 10 to what power equals 0.1. It's just dropping it down into the fraction. All right, so what is the common base for a log? 10. By default, if it's not written, it's 10. And if it's not written, you get excited because then you can use your calculator and you don't have to use your head. All right, so evaluate these common ones in the calculator. Error. Why? 10 to what power equals negative 2? Can you raise something to a power and suddenly it becomes a negative number? No, you can't. It's not possible. And we're only dealing with the real number system. All right. Yeah, okay. Thought maybe I jumped more pages on me. Okay, so I'm going to have you guys grab a partner for me, please. We will have one group of 3. I'm going to set the clock for 10 minutes. You have problems on your paper evaluating these. So can you use the calculator on these? No. So you have to kind of use your head there. And then you're also going to do these, where it wants you just to convert from one form to the other. Okay? So I'm going to give you guys 10 minutes. Anybody, you guys with your partner? I assume you're doing it by proximity here. All right, 10 minutes, guys. Let's see if we can get through all these. To check with each other. Yeah, having a partner so you can work together, help each other out, double check yourselves. You, on your quiz Friday, you'll have a page where you cannot use your calculator at all. I would probably practice without it. don't have super hard ones, no. Do you have a base on that log? Log base 64 of 4. Okay, that doesn't, you need to make sure you say base, because otherwise it doesn't make sense. Not to the trained mathematician standing before you. Want to say what? Cord? Oh, I don't call them cords. I call them cables. Yeah, I call them cables. Usually by taking square roots of something, or cubed roots, or fourth roots, or... Did you talk to your partner at all? Talk to your partner. Work together. That's why we have a partner. So 343 to what power equals 7? Could you do the square root of it? Or the cubed root of it? Okay, is it the cubed root? So it'd be... Nope. There you go. So you just go 3 times 3 times. You know you can use an exponent. Six cubed is what? 260. You're in trouble on that quiz then. You got like 8 problems. No calculator. So 2 to 2, 3. 3 to what power equals 1 over 243? How do you move the number to the bottom of the fraction? Negative. 3 would be a negative. And then 3 to what power equals 243? Well, yeah, your calculator's, you have to switch it to a... You know the negative's going to work. Just figure out to what power equals. Yeah, see, it'll switch it for you. The fraction? Negative exponent's going to move it to a fraction. Yeah, just remember the negative exponent. Did you talk to each other? Yeah. Yep, do them all. So, what does this mean? What's it asking you? I don't want the word log in your definition. What's it mean? 3 to what power equals 1 over 243? Right, but that's what I'm asking you. What does it mean? So it's asking you what 3 to what exponent equals that, right? Okay. So if the number's in the bottom of the fraction, I know my exponent must be negative. So 3 to what power equals, does that say 243? 243. I don't know either. Figure it out. Yeah. The other side, you're just converting between the two. The loopy swoopy? Do your loopy swoopy. No, we're not tying our shoes. Loopy swoopy. No, loopy swoopy. Loopy swoopy.
You okay if I write like r equals log 9x, log 9
Base 9?
Yeah.
2x?
Well,
Which one am I looking at?
that's number 2 on the second part. First column.
Okay, what do you want to write?
So it says 9 to the r equals x. I was wondering if I could write r equals log base 9.
That's a y, not an r.
That's a y.
Log base 9 of x equals, you said r per y. Yeah. Oh, you just mean write it backwards?
Yeah.
Oh, yeah, it's fine. Same idea.
That's a y.
No, that's fine. Same idea. Mm-hmm. That's how I feel too. I just want to like curl up and just go to sleep. That was a totally inappropriate use of that word. Why would you say bet when you get an answer? See, it's a totally inappropriate use of the word.
I'm sure there's some.
But that's not what people scream when they get an answer. Bet.
I don't know, some people just scream really weird things. Like,
That fell into the category of really weird
there's a game
things.
where you play and you scream Yahtzee at me. Like, that's pretty strange to
That's
scream.
because you get a Yahtzee, so you yell Yahtzee.
That's still something.
He didn't get a bet, he just got an answer.
Still something really
So you should scream answer.
fancy.
Got it. Yay! I'm so smart. I'm the smartest man in this little square right here. My brother used to always say that. I am the smartest man in this square right here. Somebody may see block. But I actually did know that. That is true.
Are you serious?
Yeah.
So if I bang my head against the wall once an hour, I then
Not once an hour. For an hour.
Are you serious?
You'd have to stand there for an hour, slamming your head against the wall.
No, thank you.
You'd burn 150 calories.
No, thank you.
And a lot of brain cells too.
Yes. I think some of my students have tried it. Can you wait just a couple minutes? Okay. We're almost done with notes. That was you. I see. I knew there was somebody. It's Jesse. No, it's not. Oh, it is. Okay, now I can record again. Sorry to anybody listening. Okay, so log base 4 of 64 equals 3. And again, it's because it's asking you 4 to what power equals 64? It'd be 3. So log base 4 of 16? 2. Because again, 4 to what power equals 16? And I think it is helpful. Some of you need to see visually what that looks like, right? Write it in exponential. So this one, 5 to what power equals 125? 3. This one, I'm too close, it's hard to read that. 343 to what power equals 7? That is 1/3. Okay, oops, throw one over there. All right, so this one's saying 64 to what power equals 4? It's 1/3. Again, that's doing your 1/3 is taking the cubed root of it. So if you notice your number's getting smaller, it's probably doing a root of it. And if it's dropping to the bottom of a fraction or moving to the top, you've got a negative exponent in there somewhere. All right, so 6 to what power equals 216? 3 to what power equals 1 over 243? Negative 5. The negative's going to make it drop to the bottom, and then I'm taking your word for it, 3 to the 5th. Okay, so this one's asking 2 to what power equals 4? I hope you got that one pretty easily.
I got 8.
All right, 2 to what power equals 16? 6 to what power equals 1 over 216? Questions on any of those? Again, first page of your quiz on Friday. I believe it's 8 problems, something like this, where you cannot use your calculator. I'll not make the numbers ridiculous. Okay. All right, and then you had the converting them back and forth between the two. So again, remember it's kind of that loopy swoopy stuff again. So it's going to be log, what's my base? 1/5 of equals x. So I'm going to use this number, then I'm going to write that one, and then I'm going to write that one. So it's the same order. Typically you see the cursive L. I think if nothing else, it's because it looks like 10G if you don't write a cursive L. Do you know what I'm saying? Because a lot of times you see the L like that and then the 0 and then the G, it looks like 10G. And you're like, wait, what was I solving for? Yeah, so it's by force of habit. I always make the cursive L. Now you see it, don't you? Yeah, that's why I make the cursive. So on this one, log base 9 of x equals y. Again, it's the same order. You're going to write this number, and then this one, and then this one. Loopy swoopy. So in order, I'm writing log base 9 is the first one of x equals y. So it's the same loopy swoopy order that they're going in. So the next one, log base of equals y. Log base of 123 equals a. Log base of, is that a B? I'm standing so close it's like pixelated from where I'm at. Questions on switching from exponential to logarithmic? Okay, going the other way, again, I think is probably easier for you. Loopy swoopy. So u to the sorry, bad copies. All right, loopy swoopy. So you're going to have do I have to have parentheses?
Yes.
Because the entire thing would be to the y power. If you don't put parentheses, it only looks like it's on the 7. So this one? This one? Good. Yeah, hopefully, I mean, again, this is just trying to get you that practice switching back and forth because you're going to have to be able to do that. All right. The rest of the time, I'll give you for homework time. So if you have questions, you can ask, okay?